Okay, so quickly, I'm going to go through this with a big overview. Okay, see if this helps out. Just kind of going through an overview of what you're doing. The whole point of this problem, or the whole point of calculus, is to find the equation of that, or not find the equation, it's really the speed of the line, of the curve, the blue curve at any point. So at any curve, you don't have a method yet of finding the speed. I gave you an example, the growth curves, why that's important. Most of what we do are curves, and we have to figure out what to tell patients, how fast or slow something's going to happen. Believe me, that's a lot of what I work on, is telling people how fast or slow something's going to happen. So the point here, I just grabbed a point as an example, x equals 1. I want to know how fast the curve is growing right at x equals 1. Exactly how fast, not approximately, exactly. Thumbs up on that? No? We're okay on that? The point has to be clear, otherwise the rest of it's going to fall apart. What we're looking for. Okay, this is the Webassign problem, which you guys all love. There it is. Has a bunch of questions. But the bunch of questions is really the first question I asked you. Can you find how fast that curve is moving right at that point? That's the real problem they're asking you, all in little pieces. So how do we do this? Well, we take that point. We put a magnifying glass on that point. We want to see exactly what's going around that point. We scoot just a little bit to the right because our plan is going to be get approximate answer. Not the exact answer, but just approximately. So we scoot a little bit to the right of that point and draw a line between those 2 points. I'm going to calculate the slope of that line. And that's approximately the correct answer because I just scooted a little bit to the right. And all this garbage after was finding the slope between those 2 points. Blah, 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 blah. Slope between the 2 points. Now done. I got the slope between the 2 points. The answer is 7 minus a. That's an approximate answer. How can I get the exact answer? Well, if a was closer to 1, right? So I'm going to slide a close to 1 by actually letting it be 1. Down, down, down it goes, and I get slope is 6. I have to remember to shut off Skype. Okay, so that's how I got 6 as my slope. And then the rest of it is all stuff that you've done since you were little. Where you find the slope between two, find slope, point slope formula. How do you get the actual equation? The equation's found by finding you have m, you have a point, blah, blah, blah. The rest of it is all stuff you've done before. And I get 6x plus 1 doing the motions. Now better? More clear? So the moral of this story is I should really go fast. It's not clear yet? Okay. Because I can go really fast.
Just real quick, when you slid A back to 1, I'm a little confused there because weren't we already at 1 with our initial point? Now we're finding a slope between.
Right. What we're doing is, I should have actually drawn this picture, and there's going to be places online that are better than this. But what we're doing is, we have this curve like this, and we have this point 1, and we have this other point to the right of 1. And I'm drawing a line between those 2 points, like that. And this is the tangent line. I'm exaggerating its differences. They're not exactly the same, right? So I get an approximate answer. And the approximate answer was 7 minus a, no matter what the a was. So if I scooted the a down to here, so that was my first selection of a. But if I'm allowed to vary it, it's called a variable. So if I scooted the a down to here, I get a better answer. And if I scooted the a down, so the slope of b between these 2 points is also 7 minus a. It would just be 7 minus a, which is closer to 1. Right? And then if I keep scooting it down, I'll get a sequence of points for the slope. And those sequences of points actually converge to 6. You actually can make a table and see that. So we'll be doing a little bit of that so you can see it in the table. Is that clear?
Clear.
So the starting at 1, why it didn't work is I didn't have 2 points. I don't know how to calculate the slope of just 1 point. I need 2 points. And this idea of a limit was a big deal, actually. Euclid, back in Greece, ancient Greece, had kind of come close to this idea, but Leibniz and Newton came up with it at the same time. Newton was physics, very applied. Leibniz is more of a theoretician, and it's usually thought of Newtonian calculus, so he got his name attached in it. And if you have examples from your pre-calc that you can think of with particles moving, motion, the reason for that is everything is revolved around Newtonian calculus. He was using it to look at planetary orbits. So that's why. We're in the physics is in our department, so I shouldn't say this too loud, but I never was a fan, you know? They never seemed to interest me that much. Particle moving around, I don't really care. I know it's really important, but to each their own. You guys have to take that too, right? Physics?